In this video, we'll be going over the memorization approach of unique binary search trees. Let's go over the thought process. So in the recursive approach, the solution was very inefficient due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. Now, what do we need to cache? In each of the recursive call, we are trying to find the number of binary search trees for each of the value n. This means we can cache n with the number of trees. Let's go over the pseudocode. So we're going to create an array, Memo, to cache previously calculated results. So the indices represents n, and the values represents the number of trees or binary search trees. And then we can implement the top-down memorization approach. And then we'll pass in our Memo, is our cache, and then we're going to put a new base case saying if Memo n is not equal to 0, this means we have already calculated the results for n, so we can return the cache results. Then inside our recursive calls, after we have found the total number of binary search trees by checking through all of the roots, all the possible roots, which we call I, then we're going to want to cache the total number of trees. So we're going to put trees at Memo n, then we can return the total number of trees. Let's go over the code. So we're going to create another method. Then we can return the number of trees with n and pass in a new array, which is our cache, with n plus 1, because we want it to be 0 to n. And we can pass in our Memo. We want to set this to private. Then if Memo n is not equal to 0, we have already calculated the results for n. Then we can return the cache results. Then we want to cache the total number of trees at Memo n and also pass our Memo to our other recursive calls. Let me know if you have any questions in the comment section below.